Hi, I'm Tolga, Onica's CTO.
I'm William, the Director of Solutions Architecture here at Onica.
So Will, let's talk today a little bit about hybrid and multi-cloud environments, and specifically around the tooling. We hear customers say they want a consistent set of tooling across both their on-prem environments and their 2 or 3 cloud providers. But in practice, we find that to be pretty challenging. Can you tell us a bit about what's going on here?
Yeah, there's always a drive to use a consistent set of tools. And the problem with that usually comes about in the sense that the tool is going to enforce a set of standards that might not be most beneficial for each individual platform. So if you're running on-premise or if you're running in a group of cloud providers, what you're going to end up seeing is a single tool will tend to default to the lowest common denominator across all these platforms, which inevitably is something like virtual machines or EC2 instances in AWS compared to a virtual machine on-premise, for example. Right. If you're using these lowest common denominators, you're really not getting all of the benefit. You're not squeezing all the juice out of the cloud platform that you're choosing. So typically what we end up seeing is that you don't get any of the benefit and you just end up running another data center that costs more than on-prem, for example.
So what about these tools that purport to be sort of multi-cloud, like Terraform?
So Terraform is a really good example because it does support many platforms. You can write automation and infrastructure as code for VMware, for AWS, for Google's cloud platform, Azure. It supports many things. The problem is people think that you can just write one Terraform template and deploy it to any platform. And that's simply not the case. The way that it interacts with each of those platforms is entirely different. So you would end up writing the same template 5 different times to support each one of those platforms individually. It's a good tool to tie interactions together because it can talk to them, but it doesn't necessarily mean that you're going to have less work involved.
So what about these tools that are even a higher level of abstraction, like, hey, don't code against the AWS APIs. Here's an abstraction that works the same across multiple clouds.
Right. The tools that abstract these processes, they can seem really glossy and shiny on the outside because you don't have to worry about what's going on under the hood. Inevitably, what we've found is that you will end up having to dig under the hood to solve problems, and so you kind of lose the benefit of all of that abstraction. The other thing is that they tend to fall back on those lowest common denominators in order to make the abstraction work. And inevitably, it's a flawed system. The best approach is always to go for using the best tool for the job in each individual situation and trying to tie those back to a consistent workflow.
Right, so more about normalizing the workflow, less about normalizing the exact tools.
Right, because if you try and abstract things away, it's kind of just going to fall apart.
Yeah, I've heard those called leaky abstractions, where you have to become an expert not only in the thing you were trying to abstract away, but then you have to become an expert in this abstraction layer because it has some limitation to overcome.
Yeah, that's a perfect description.
Yeah, good chat. Thanks, Will.
Awesome, thanks.